Welcome to Flutter Maps SDK Advanced Workflows. I am Paul Sturm, and this is Jen Marriott. We're on the Maps SDK for Flutter team. And before we get rolling, we did have some questions for you. I was curious, who here was at yesterday's building apps for Flutter session? Yeah, so I figured I probably should come up with a different set of questions to ask this time. Who here is evaluating Flutter for adoption for the very first time? Like brand new to Flutter, wondering if it's worth checking out. All right, good. That's what I thought. About half of the people are going to be brand new. Is anybody here already shipping an app with Flutter and the Maps SDK? Oh, all right. So you're in production already with real customers? Pretty soon, yep. Our next major release will be out in about a month or two, so you can update, or not update, I don't know. All right. Okay, so also we have this feedback page in the Esri events app, so share your feedback at the end of the session, not before. And then, okay, so here's our agenda for today. First, we're going to take a look at widgets and layouts and some of the patterns we're using with our SDK. Then we're going to dive into asynchronous programming and how that is handled in Flutter and why asynchronous workflows are important to the Maps SDK. Then we'll take a look at some state management and architecture considerations. And then afterwards, we'll take your questions and then offer up some next steps. So first, widgets and layout. So if you're new to Flutter, or if you've been working with Flutter, you understand that Flutter is built on widgets, and everything is a widget. And widgets are the usual UI controls like buttons and switches and text fields, as well as layout elements like columns and stacks. So you define your UI as a complex widget built by composing more basic widgets together. Then secondly, the Flutter framework drives your widget through a lifecycle. First, it'll call your init state method. Then it repeatedly calls your build method to get the layout of your UI given the current state. And then as your app's state changes, your build method is called repeatedly again and again. And then at the end, the Flutter framework will call your widget's dispose method. And it's important to note that Flutter is in charge of driving the lifecycle and driving the general flow. And so in your build method, which you write, your task is to describe the UI as it should be given the current state of your app. So that means what widgets should appear, the values that they display, whether they're disabled, and so forth. It's important to note that it's the Flutter framework that drives the conversation. When something changes that affects the state of your widget, Flutter will call your build method and ask for a new description of the UI. It's then up to Flutter to make the necessary changes to go from your previous description to the current description of the UI. And then to finish out the conversation, whenever something changes in your app, you would call the set state method, and then the set state method informs Flutter that something has changed and we'll need an update. And then so that will cause Flutter to ask for your newest state of your widget by calling your build method again. So that's the mental model. You got to get used to that. You're not in charge. Flutter's in charge, and Flutter's going to ask you to describe your user interface. And then Flutter provides a large number of widgets that you can use to define the layout. The common ones are row, column, and stack. And then there's also a widget called container, and you can use that to describe your borders, background, margins, paddings. And so to produce the overall look, your job is to compose multiple widgets together That the widgets are intentionally designed to focus on its own specific purpose and to be composed together with other widgets. And then the way the layout system works, like really briefly, the parent widget provides size constraints to all of the children widgets. Then the children widgets provide their computed size back up to the parent, and then the parent lays them out on the screen, providing them their coordinate position on the screen. And then if there's a problem with the layout, one common thing you'll see is a black and yellow striped overflow marker will show up in your app, and that'll be the indication that you've made some sort of mistake. You've tried to fit too much into along a single dimension, and Flutter is telling you that it can't work out your layout. And so that tells you have to go back and work it out, figure it out. So for this first part of the demo, Jen is going to step us through those things, and I have to find the right button 5.
Yep.
And we're up.
Great. Yep. So in the demos in this talk, I'm going to be presenting an application that I'm going to gradually kind of build out and refactor to demonstrate some of the concepts that Paul's introducing. And I think one key point to make is that there aren't really strict rules with Flutter in terms of how you implement an app, like maybe you see with Swift, where you have kind of quite strict guidelines on how things look. As Paul said, it's really about putting together these widgets and how it works best. So we're going to show some ways of doing things, some things we've found useful as we've been on this journey working with Flutter over the last couple of years. And we'd really encourage that you kind of think about the reasons why you might choose a particular workflow or pattern. Do what makes sense for kind of your team, the kind of patterns that you implement as a team, also your workflows and your app, and also, of course, ultimately the users of your application. Another thing to say as well is that there are a lot of third-party packages available with Flutter that can make life easier and add different capabilities. In this demo, we're going to kind of focus on using vanilla Flutter. So, and, well, of course, our SDK package as well. But there is a lot you can do out of the box, and we'll go into some of the key concepts. But there are packages out there that kind of will do a lot of this for you as well. But it's really just, again, choosing what works for your team and your app. But all that said, I'm in VS Code, and I've got this app running here on my 2 simulators. It's a simple map with the ArcGIS map view widget within a scaffold. We're showing our current location, and we also have this feature layer displaying, which is points of interest around Palm Springs. And we can hook up this on-tap callback to add interactions on our map view so that when I interact and tap on a feature, you can see that that's selected. And if I dive into the method that I'm calling from that callback, we're identifying on our feature layer using the position that we've tapped. And then when I find a feature, when I tap on a feature, we're using that set state call that Paul was talking about, and we're capturing this identified feature in our state. And we're also selecting it, which is why we see this kind of little halo here. So I'm going to be adding some more UI to this app so that we can see the name of the identified feature, which will ultimately be a destination, and then we'll calculate a route from where we are to our selected destination around Palm Springs. So that's kind of the plan that we're going to follow. So the blue dot, first of all, is displayed in the map thanks to our system location data source, which is using the device GPS to get the current location. And we then use this location display property on our map view controller to actually display that in the map. So for adding some UI, there's different options I could take here. I could go down the route of using a stack widget. So laying controls kind of over the top of each other. So maybe they're like a button over the top of the map, for example. If I just scroll up to the build tree, we could use properties on this scaffold widget, which are really useful. So there's like an app bar, there's floating action buttons, and there's a drawer, some of which we'll kind of see later. But what I'm going to do here is actually display my controls beneath the map, so kind of in a column. And so to display the map view in a column, I will wrap it first of all. And then Paul mentioned that some widgets don't necessarily define the bounds for the children, and column is in that category. So we actually need to wrap the map view in a column, in a parent widget, with a bounded size. And so the best way to do this is to use an expanded widget. So if you're using your map view within a column, we really recommend the expanded widget then. Basically means the map view then takes up whatever space is available from other controls. So then beneath my map view, I'm going to start to add my other controls. So I'm going to add a text button, and this is going to call a method that I've already configured called calculate route. Give myself some real estate here. And I'm going to set the child of that to some text that will calculate a route. And we can set that to be const, since it's not going to change. And we can see there, using hot reload, we've got the button appearing at the bottom. But what we can also see is that, particularly on iOS, we're kind of starting to run into the edge of the device there. So what I can do is actually wrap my column into a safe area. And if I hot restart this time, you can see that that's much, much tidier. And we've got a lot more space, kind of avoiding any of those kind of device elements. But you'll also notice potentially that up the top now, we're kind of stopping the map at the top safe area as well, rather than kind of flowing to the top of the app. So you can actually use properties on safe area. You can turn it off at certain places. So if I hot reload now, you can see the map kind of flows right to the top again. So it's quite a nice way of being able to play around with how your app looks. So now I want to get back to my UI at the bottom here, and I want to display some feature information. So I'm actually going to wrap my button here in a row, and then I'm going to add some text. And initially, I'm just going to say select a destination. And you can see that's added into my row. And then I can use these alignment properties on the row to kind of space them out a little bit. And just to make things a bit easier to see, I'm just going to bulk this out with some padding as well. All right, and finally, there's one more UI component I want to add to this sort of controls area, which is another button, which is going to call another method that I've configured to clear my route. So add the text for that as well. And again, this isn't going to change, so I'll set that const. And then now if I select a feature, I can calculate my route from my current location to it, and also clear that off the map. So right now, this text is telling us to select a destination, which is kind of helpful when we haven't selected one. But when we have identified a feature, we want this to actually display what I've selected in the UI. And so we can now start to make use of that identified feature variable that we've captured when we've performed our identify on our feature layer, and we can conditionally display this text. So I can check whether my, that should be identified feature, check whether my identified feature is null, and if it is, in other words, we haven't selected anything yet, we'll instruct our user to select a destination. And if we have selected an identified feature, then we can actually access now the attributes for that feature, and I know that it's got this name attribute, and you could configure that in your feature layer. So when I hit save, select a feature, you can see that we're now selecting a feature on our apps. So this is a kind of improvement in terms of selecting and seeing the information, but obviously the feature names can be quite variable. So if I select this feature down here, which I know has a longer name, we see that error that Paul mentioned, very common to see, which is this overflow error, which basically means that everything in my row is just taking up however much space it needs. And in this case, we're overflowing the space that's available. And so this is where Flutter is then telling us, you need to kind of do something about this. So again, we can make use of the expanded widget to wrap our text. Since our text is the one that we know is going to change, if I wrap that in an expanded widget, you'll see that it kind of wraps, and it then takes up the space that it has available. So we've kind of got a nice little app here running, that we can use across both platforms. And one thing that I also want to point out here, that's quite useful, is that Flutter comes with a whole suite of dev tools, as well as the VS Code plugin, which you kind of seen all the sort of code completion and the shortcuts, which are super useful. But with dev tools, we can debug into one of our simulators while we're working and see all kinds of information. So within VS Code, that's just available on the side here. And if I go into the dev tools, select my simulator, so I'll choose my iOS simulator, and then I can open these in the web browser. So it pops this window open. And there's all kinds of things that you can make use of in here. There's like an inspector here where we can dig into our widget tree if you're kind of a visual person. And you can dig into like the state of this widget and kind of look at all the different properties. There's various performance and memory related options, one of which we're going to take a look at in our demo theatre tomorrow, if you're able to make that. There's also some advanced logging as well, but one I want to just call out that I've found really useful at times, particularly with using services, as we do a lot with ArcGIS, is the network tab. And if I reboot my app, we'll see all the network calls to the various services kind of pop up here, and you can literally kind of go through those, interrogate what's happening in the network calls. If I perform an identify, we'll see that query going through. And so if you're kind of seeing issues perhaps with data or the responses from servers, you're not quite sure, it's a really useful way of debugging into that and finding out what's going on. So that's the first demo. If we switch back to Paul for introduce some more concepts.
All right, so here we are. All right, so key takeaways. What did we see in the widgets in layouts demo? First, you have lots of widgets and options available to you. All the different ways to set the scaffolds, buttons and drawers, or adding budget or buttons and switches. So Flutter has a wide set of widgets to work from that you can use to build out your UI. And then second point, when you are composing your widget in the build method, you're going to be using conditional logic to decide what widgets are included, their properties, what actions are tied to those widgets, and so forth. And then a state change might impact just a small part of the UI, or it could completely change the whole presentation. And one widget we saw was the safe area widget that helps you avoid areas of the screen that are clipped by hardware or OS level controls. And then another widget we saw was the expanded widget, which will have your map view or other widget fill the available space. And then lastly, as you're building out your user interface, Flutter provides several dev tools, which help you do things like inspect your layout, detect performance problems, and investigate memory issues. And then next, we're going to look at asynchronous programming. We'll see how the Maps SDK performs asynchronous work and how that fits into Dart's async await syntax. So here's a little diagram. So first, let's look at the asynchronous work that the Maps SDK will do on your behalf. The Maps SDK performs many asynchronous tasks, such as accessing network resources or performing computations in the background. And generally, this means you initiate a task, and then at some time later, you receive an indication that it has finished or that it failed. So one common pattern used by the Maps SDK is our loadable pattern. And this is shown here in the diagram on the right. A loadable object will start in the not loaded state, then it will go to the loading state, and then either to loaded or failed to load. And in your code, you initiate the process by calling load, or the process can begin automatically, such as when you add a map to a map view and display it on screen. And also a parent object will recursively load its children object, such as a map loading all of its layers. And then the load status of an object will change over time as it moves through each of these states. And then keep in mind that in some cases, certain properties on an object are not available until after it is loaded, such as information that was retrieved over a network. And then lastly, if there's an error, an ArcGIS exception is raised, and that will describe perhaps a networking failure or some other error. And then if we look at how Flutter handles asynchronous work, it starts with the future class, which is part of the Dart async library. A future is a handle on a promised result that will come at some point in the future. Once a future completes, the result of that computation is made available. And if a problem occurs, you'll get an error rather than the expected result. And so the future class has a then method, and that's how you specify what should happen when the future completes. Usually that means you're going to take the result of the task and perform the next stage of processing on it. And then to handle errors, the future has a catch error method. And then the future API provides several additional ways to control asynchronous tasks. One such option is the future.wait static method. And then you could use this to combine multiple futures into a single future that completes when all of the input futures complete. So you can do a whole batch of asynchronous work, and then in one call you can say, once all of this work is completed, then call me back so I can work on the next step. And then as an alternative to using the future class and these methods, you can use the async await pattern. And the async await accomplishes the same thing as then and catch error, but with an easier to follow syntax. It lets you write your asynchronous code more linearly and handle errors with a normal try catch block. And so to use async await, you mark the body of a method with the async keyword, and then you use await to wait for the return value of a future. And so the task is still happening asynchronously, but now the complexity is hidden behind the await keyword. So all of this is happening at the level of the Dart code. And then to integrate this with your user interface, Flutter provides widgets that work with futures. One such widget is called Future Builder. And then with a future builder, you pass it a future along with a callback that you write to provide the appropriate user interface for each state. So you define what to show when the Flutter is in each of those states, when it's in progress, when it completes, and possibly when it finishes with an error. So as we saw on the last slide, the Maps SDK provides this loadable pattern. So for any of those loadable objects, when you call load, it returns to you a future. And then you can apply any of these techniques to that future. So we're going to jump back to Jen's computer to look at some of these concepts. Bump.
Great.
All right, you're live.
Thanks. Yeah, I'm just going to use the one simulator now, so hopefully bump the code up a little bit as well. So we're starting off from where we left off in terms of the functionality in this application, and just sort of look at some of those concepts Paul's just introduced through in the code. So there's a few examples of loadable and async patterns in this application already. So if I go into this calculate route method that we've previously defined, we can see that we've got our async await pattern that Paul's just been talking about being used in this method, and we have the method signature being marked as asynchronous. And each of these operations returns a feature. And we need to wait for these to sort of finish sequentially. So we need to wait until the route parameters are created because we need to use them to solve the route. And then we need to wait for the route to solve before we can access its geometry to display it. So that's kind of the pattern here. And Paul kind of mentioned the .then notation as well. So just to show how that would be written in the equivalent notation. So you can see that we're achieving exactly the same thing here. We're initially creating the route parameters, and then we're solving the route, and then we're displaying it. So it's doing the sort of same thing, but I mean, personally, I kind of prefer how it looks with that await notation. It's kind of a little bit clearer, looks a little bit more convoluted and modeled here. So you can see why the kind of await pattern is generally the recommended approach, but just depends on what you're trying to do in your app. And in terms of error handling with asynchronous operations, we can use this catch error call when we're using the .then notation. And yeah, the operations from our API return ArcGIS exceptions or throw ArcGIS exceptions where errors do occur. And they can be quite useful to get a hold of because we do try and provide as much useful information as we can. So if I just capture this, the error that's coming from this method here as an ArcGIS exception, you'll see I get access to these message and additional message properties, as well as some other information about the error. So you can kind of make use of that within your applications. It might be that it's something you can display in the UI to users, for example. And in terms of error handling with the async await approach, I'll just comment this code out. It's really just a case of wrapping your async await calls in try catches. And here I've got kind of one sort of larger try catch statement, which is wrapping all my calls, but you could just as well have a try catch wrapping each of your asynchronous calls, and it would otherwise run through in that same kind of linear method. So I'm just going to go back up now to the on map view ready method, which is a callback that's called once the ArcGIS map view widget is kind of ready and fully displayed. And we're calling three helper methods here, which are setting up the map and the data, so the map and the feature layer. We're initializing everything needed for the routing call, and we're also initializing the location data source and location display. And I'm going to concentrate just on this init map method here, which I've configured. And we can see that it's got our map, it's defining our feature layer, which is from a portal item. And as Paul introduced, the concept of loadables, the map, the feature layer, and the portal item are all loadables. Now, I'm not actually explicitly calling load at any of these points. They are obviously being loaded because we can see them here on the map, but they are being implicitly loaded by being added to our map view through our map and sort of cascading down into the layers that the map contains. We could explicitly load these as well, but as I say, in this case, we're not. Now, if I break the URL and then rerun my application from the start so that this method gets called again, we'll see that the map has loaded fine, but I can't see my feature layer. And if I hop into the console here, you can see that we've actually got these warnings being printed out, which are showing that the portal item, since its URL is broken in the feature layer, have not loaded, but they aren't being explicitly thrown, and that's because of this implicit loading. However, if I was to now call load on our feature layer, and we need to set our method signature now to async since we're calling await, And if I reload this now, then we'll see we get that exception thrown. So again, this is things to think about when you're building out the workflow of your app and what you need. So in this case, I could then implement a try catch like below. And using our ArcGIS exception, we would be able to then do something to display to the user. Perhaps in this case, we wanted the map to load, and then we maybe display a message about whether the feature layer has loaded or not. But what we can also do is display content conditionally based on whether or not a future has completed successfully, completed with errors, or is in progress. So that's what I'm going to do in this application now. So in that case, what I actually want is for us to go back to our load methods throwing these load errors. So I'm also going to wait for my map to load as well. Right, let me just make sure I'm walking through these steps correctly. So the first thing we're going to do, rather than calling our initialize steps in this onMapViewReady method, which we're doing right now, I'm going to add the init state method, which Paul introduced earlier for how we can do some configuration as we set up the widget. Now you'll see in a lot of our samples that we often do a lot of configuration in the onMapViewReady method. And a lot of the time this is so that we have a kind of sequential story of how we build up the data. But you can get some optimization by initializing things in the init state before the widget tree is built. It just depends whether the operations require that the map view widget is fully loaded and ready to be interacted with. So the problem with init state in some ways is that we can't now call asynchronous operations. It's just not possible. So what we can do though is kick off asynchronous operations. And then what I can do is actually create a future object in my class that can track how that future or how that operation is going and see when it completes, and also see whether it completes with errors. So I can define a future in my class, and then I can capture the status of this mapLoad method in my mapLoad future. And one thing I need to do now is to make sure that my method is returning a future. And so this method is going to return the outcome of the futures that are, or the asynchronous calls that are happening within this method signature. So now what I can do is make use of the future builder that Paul mentioned, which will track this future I've created and display content conditionally based on its status. So for the sake of time, what I'm going to do is just replace my widget tree here with a code snippet, and then I'll walk through the configuration of the future builder. And if I hit restart, okay. So we've still got the scaffold at the top of this widget tree and our safe area that we had before. And here we're introducing this future builder. And it's got this future property, and we've assigned to it our map loading future. And the future builder comes with this snapshot, which is tracking our future and listening for changes. So this tracks when it's completed. And then we can also then see when it is completed, whether it has completed with an error or without an error using this has error property. So firstly, I'm going to scroll down to the bottom and we'll see what happens when we have this, the default scenario. In other words, it has not completed, so it's in progress. And if I just restart the app again, you'll notice we have this text loading data. When the future completes, and it completes with an error, which it is doing right now, because if you recall, we broke that feature layer URL, then we display this column here with an error message, which is from our ArcGIS exception. So you can see how that string can be quite useful. And then we've got this retry button here. So I'm going to go ahead and just fix up my feature layer. So excuse the scrolling around as I do this. And now when it loads successfully, and it does not have the error property, we come down into this statement here. And then this is that same URI that we were seeing before with our buttons at the bottom and our map view displaying once our map and feature layer have loaded successfully. So we can take this up another level and bring in another UI component that has some data requirements just to show an example of the batching of asynchronous calls that Paul had mentioned. So I'm just going to call a different demo here. So bear with me while I rerun this. Okay, and I'm just going to attach to the DevTools as well. So I'm going to open those in the browser, try and make them a little bigger for you if I can. Let me go into this logging area, and I'm going to filter for base map because I want to look at some print statements that I've applied. I'll just toggle back to my application and we'll pop back into the DevTools in a moment. So we can see that in the UI we now have this button in the top right, which is a drawer within the that opens a drawer within the scaffold. So this is a really easy way to implement the kind of drawer widget within your application. And it contains another feature builder, which in this case is the base maps feature. And as it's loading, it will say loading base maps, and then once it's successful, it displays this list view builder with the list of base maps and the thumbnail as well, and then you can kind of update the base map within the app. One thing just to note here is that the list view builder is a good widget to use for an unknown list length, especially if it's likely to be a long list or if you know that it's a long list. In contrast to a default list view constructor, which creates all the items at once, the builders generally create items as they are displayed on screen. So for example, as you scroll. So that can be one useful optimization. So what about the base maps themselves? So I'll go to where this feature is defined, and you'll see that we are setting that to the outcome of this load base maps function. Now, if I bring up my DevTools at this point, actually, I'll just explain the code first. So we're grabbing our developer base maps from ArcGIS Online, so it provides you with a list of base maps. And then I'm looping through that list of base maps and loading each one and its thumbnail. So now I'll just hop into the DevTools. And if I hot restart my app, hot restart. As it's loading. Here's a hot reload or hot restart. It's not feeding them through. Okay, let me try it from here. Nope. Okay, I will reboot. So the key point here, and I'll show it in the DevTools in a second, but in this case, we're actually waiting for each base map to load sequentially. So we are loading base map 1, base map 2, base map 3, etc., etc. But actually with the base maps, what we want to do is to just fire off and load all the base maps all at once. And so if I try now, I'm going to reattach. Maybe the connection. Okay. Try the filter for the base maps. Maybe the Wi-Fi that's letting me down here, but we'll see how this goes. And if I restart now, we'll see that the base maps are loading kind of one by one. So you see how they're printing out one by one. We see this loading base map screen, and it's kind of took quite a while for that loading base maps message to disappear. Whereas if I switch this call out here where I'm looping through and I instead batch these calls together, so rather than waiting for one by one, what I'm saying is load all these base maps all at once and tell me when they're done as a group. And you'll see if I now rerun this, just how much more efficient that is. And I'll barely have time to see the loading base maps. So you can really see where maybe you're loading a lot of layers that aren't dependent on one another. That's going to be a really good optimization to make. I'll hand that back to you, Paul. Thanks.
Yeah, okay. Okay, so here are key takeaways that we saw in the async demo. First, we saw the importance of understanding the asynchronous patterns when working with the Maps SDK. We saw that there are several different approaches that can be taken with trade-offs between readability of the code versus the power and expressiveness of the more advanced parts of the future API. We saw some optimizations you can make by thinking more deeply about the tasks that need to be done and how they're dependent on each other. And then we also saw the future builder widget in action, which ties your future objects to your user interface. And then finally, for the third part, let's take a look at how you can manage state and structure the overall architecture of an app. So when it comes to choosing an architecture for your application, there are many options to choose from and many opinions on which is best. I have mine. The trade-off generally involves how much boilerplate and setup is required to satisfy the architecture pattern before actually delivering user-facing functionality. There can be a large startup cost up front. And that cost can be warranted for an application that is expected to grow into a large code base that needs to be maintainable over the long term. And the architecture model you choose will lay out a pattern of separation of concerns, providing a modular or a layered approach to keep each component focused on just what it needs. Generally, this will mean moving your data and logic into a layer of model objects, while your UI layer on top of it will be focused on only presenting the data. And the benefit of that is that it'll make your code more testable and maintainable. And then so one key component of your architecture will be your approach to state management. As we saw earlier, your user interface is driven by the build method, which examines the current state and responds with the corresponding widget tree. You'll need to make sure that the relevant state is available to your widgets while minimizing the work that is triggered to rebuild the affected portions of your UI. So I'm going to switch back to Jen's computer to take a look at those concepts.
Thanks. Yeah, so this is the file that we left off with just before, and I'm kind of starting to hope that you're maybe like cringing slightly at just how much is going on in this widget tree. We've got a lot of indentation here, a lot of brackets, and it's just about manageable in an app this size. So arguably the refactor that I'm going to do is like slightly overkill for this size of application, but to keep it manageable for the demo. But again, it's all about what workflows work for you and maybe what structures work for you and your team and what kind of approaches you prefer. And we're just about sharing some strategies here that you might consider when approaching kind of restructuring your app out of this kind of like one file structure that we've kind of been seeing so far. So I'm going to write a bit less code in this part of the demo. I'm basically going to walk you through a sort of refactored demo of what we've been seeing so far with some different ideas to show. So here's my new project, and this is what I'm running in the simulator here. And we have this main.dart file, which again is the entry point for our application. We're just going to ignore for now the provider and model that we've got, but we're calling this main app widget, which is a stateless widget. And it's using a future builder here, which obviously looks familiar. And its future is an initial call to this init map method, which also looks familiar. But our widget tree here is slightly different, and we have a stateless widget here rather than a stateful. And we also have these specific widgets for when we have an error and when we don't. So for example, as our data is loading, we see this loading widget, which is the this has this progress indicator now that we see, and this text saying loading data. And if I just go into my file structure here, we have the lib directory, which is kind of the starting point for where all your Dart files are for your Flutter app. And you can see that I've kind of started to structure my app a little bit. So I've broken out some of these widgets into separate files. So for example, the loading widget, and we also have the error widget, which is similar to what we were seeing within the widget tree before. So if I go into map app, which is kind of the main page for my app, I've not implemented any page-to-page navigation really in this app at this level, but we do have kind of this main page, which is this map app. And the main thing really to observe, hopefully, given that it kind of fits on the screen here, is that the build tree is a lot easier to read and a lot more kind of condensed. And we're describing the UI in a couple of ways here. So this drawer here, the base map drawer, is a separate widget. So I've created a base map drawer widget, which is loading our base maps as we saw before. And then I'm also utilizing a helper method here, which is building these bottom controls. So this is within the same file. And it's a method that's just returning a collection of widgets here. It can be easier to keep things in one file, especially with like smaller apps and widgets by using these helper methods. And we often, again, utilize these in our samples as it makes workflows easier to follow and also to explain, to kind of new users. On the other hand, if you're implementing, say, tests, it can be a lot easier to write new widgets so that you can actually get hold of the widgets rather than using helper methods. It does make widgets easier to identify. The other thing to bear in mind is where set state is called, it builds the entire widget tree. So if a widget has state that only it really cares about and it doesn't massively affect elsewhere in the app, it can help to keep that separate and sort of within itself. And there's a great video by the Flutter team on their YouTube channel that kind of talks about the pros and cons of creating your own widgets versus helper methods. So I definitely recommend that. The main other thing to point out then, sort of on that note, is that we aren't calling set state in this app, map app anymore. So we've attempted to move as much of the business logic out of this app. And you can see that we're getting hold now of our logic through this model. And if I click through to this map model class that I've created here, you'll see that this extends a change notifier. And this is core Flutter again. There's no packages being used here. And I'm initializing all the kind of familiar content that we've seen in previous demos, like our map and our feature layer and our identified feature. And we're also, this time we're loading our base maps up front so that we have this concept of a selected base map. And then at the end of this initialize method, we're calling notify listeners, which means that anything that is listening to the state of this class will know that something has changed. So the feature layer has been loaded, for example. And our map, if I go back into map app, you'll see that the map being assigned to our map view controller here is now coming from our model. So back in the model, the other thing that I'm making use of here are these value notifiers. And they hold a value that changes. So if we look at our app here, when I tap on a feature, we have a widget here that displays the name from that feature, as we've seen before. And there's actually only 2 widgets in this layout that really cares about whether or not this identified feature has been selected, and that is the calculate route button as to whether it's enabled, and also that label. And if I go into our map app and scroll down here, we can see that our identified feature label here has this value listenable builder. And so what that means is that this particular widget is the only thing that will rebuild when the identified feature gets updated. And so that can be a really efficient way of rather than rebuilding your entire application from the very, very top of the widget tree, just rebuilding in these specific areas. So how exactly are we getting hold of this state within our app? So if I just go back to main, when I first introduced this section here, I said we'd come back to this map provider, which we're wrapping our top level app in. And so if I go into map provider, you'll see that this is what's called an inherited widget. And this means data can be accessed by any widget in the subtree below it without explicitly passing it down every level. Another option from our main method, we could potentially define our state within our main app and then pass it through to our widgets, much like we've done with the load error widget here. But you can imagine that up to a certain point, it gets quite difficult to kind of keep track of where the state is and how you're passing it down, and you end up passing it down maybe multiple levels, which again, it can work in some instances, but once your app starts to build out, it can be useful to have this central place where your state is stored. And as I said, your model then is this change notifier. Now, the way this app has been set up, again, these are all using vanilla Flutter classes, but there are packages out there that provide wrappers for these things and also have their own classes and kind of structures to managing state. There's one package that's very popular, and I believe the Flutter team even promote this now, which is Provider. And that is literally a wrapper for this inherited widget change notifier structure. And it basically handles the wrapping of those classes for you and provides some useful notation to kind of simplify some of the calls we've seen today. But I think from my experience, it's useful to just understand those underlying principles of some of these packages. And then that way you can make that informed decision on perhaps which package it is that you want to pursue for managing state. And so that's the underlying message from us really, is do what's best for your app and your workflow. And back to you, Paul.
All right. So in this third part of the demo, we saw our app getting refactored to lay in some foundational patterns for structuring and organizing the code. We saw the project laid out in the file system to categorize and group the classes by purpose. We saw separation of concerns by splitting out our business logic into model classes, and also by breaking down our single large widget into smaller widgets. And we saw one particular approach to state management. And when considering how you will handle state management, one common pattern you'll see is that data flows in a single direction. The UI layer makes requests to the model layer, which determines what ought to change, and then those changes are propagated back to the UI layer. And that model layer should hold a single source of truth for any piece of app data to prevent different parts of the app from getting out of sync with each other. And then in the demo, we saw the change notifier class and how it can be used to control that flow of data between your user interface and your model. And so in the demo, we used sort of vanilla Flutter built-in widgets with inherited widget change notifier and value notifier. And then there are several third-party packages that each have a different take on state management. Some of those packages are Provider, and then there's like RiverPod, and there's one called Block, which is BLOC. And then once you understand the basics, it's worth considering adopting one of those packages And that's going to be a fundamental decision that shapes the rest of your app. So definitely take the necessary time to make that decision. And then we're coming up on the end. So with 5 minutes left, do we have any questions?
Yeah, where can we find this package?
Pub.dev.
Yeah, so
sorry,
pub.dev
repeat
is-
the question, shall we, for the recording?
Right, yeah. So the question was, where can we find these packages? They all live on pub.dev, which is the, that's the
Package repository?
package repository for all the Flutter and Dart packages that are available. And yeah, there's a lot of discourse on the internet about the state management providers and the different packages. So you can sort of join that discourse and see what people are saying and make a choice, make decisions about what package you end up adopting.
Any thoughts on the block map? Like, what do you guys feel about that?
So, any thoughts on the block?
Yeah, right. So block is one of the more robust packages, and it's more opinionated. And so if you adopt block, you go from writing Flutter apps to writing block apps, which is fine, if it's good and if it works for you. But yeah, that's definitely one of the more opinionated packages that will lead you through what they have determined to be the best approach. And then you might disagree or might agree. If you like it, if you take to it, then it makes a lot of sense. But if you disagree with it, then you would be, I don't know, it wouldn't be pleasant to have to work with it every day. So definitely compare the different packages, and like there's this broad array on the left it's going to be the ones that are more of a lighter touch, and on the right are the ones that are more opinionated and drive the decisions for you. And block is on the far side of the opinionated packages.
Yeah, and I think because as a team, I guess we don't, do a huge amount of app building in terms of, you guys do the app building and we kind of provide the technology. But when we do, I think we've generally found it sort of easier to bring in the likes of provider and those value listenable builders and that kind of thing into whatever structure of app it is that we're working with and whatever size of app. As Paul said, once you get into some of those packages, which might work really well for your organization and might be really tidy for what you want to achieve. But I think, if you're initially wanting to just play around with state management, I definitely recommend checking out provider and some of those classes that we've shown today as a kind of starting point.
It's almost better to kind of build it yourself once, like with the manual way, so that you understand the value that these packages provide, and then you can evaluate them a little better. Other questions?
Great.
So if not, there's some next steps you can take. So I have a list of related sessions. Yesterday's session was on building apps. That was recorded and live streamed, so that's available now on the website. Then tomorrow in the demo theater, we're going to do productivity tips and tricks for mobile development with Flutter. That's tomorrow at 1:45. And then for a look at new features coming to all of our native maps SDKs, the Road Ahead session is tomorrow at 5:30. And that will also be your opportunity to give feedback to product management. You can corner them in the hallway and tell them what you think. Tell them I sent you. All right. And then other than these sessions, you'll find me and Jen on the expo floor for today and tomorrow. And if you would, as a personal favor, look up our package on pub.dev and hit the little like button. I looked at it Monday night and we had 25 likes.
We've had any.
Last time I checked, we were up to 26.
Oh, yeah.
So somebody did that for me. And then share your feedback in the Esri apps on this session. And then you can also connect with us on social at all the usual channels. And then that's it. Thank you for coming.
Thank you very much.